In this module, we will discuss petrophysical rock typing. Rock typing is an important part of petrophysical studies. It enables the identification of rock units or zones with similar properties such as porosity, permeability, lithology, and fluid saturation. This information is essential for understanding reservoir heterogeneity and making accurate predictions on fluid flow behavior. Rock typing is essential for building accurate reservoir models and performing fluid flow simulations. By incorporating rock type information into reservoir models, engineers can capture heterogeneity and simulate fluid flow behavior more realistically, which improves reservoir performance predictions and assists in well placement decisions. Nowadays, with unsupervised learning techniques, you can choose a set of logs and tell the algorithm how many rock type clusters you want. Additionally, relatively sophisticated rock typing methods are available, such as hydraulic flow units, the global hydraulic element, the Winland method, and so on. However, rock typing can also be done using a calculator if you do not have the machine learning tools or core data needed for creating sophisticated rock types. The results will vary compared to the mentioned techniques, but still useful. So we will look at a simple example of rock typing in IPE. Once you get an idea of rock type calculations and visualization, you can try other methods on your own. To display a cross plot, and let us use the effective porosity and shale volume as discriminators for the rock types. Okay, so let us apply. One more thing is we will do it for the entire well, so we will not play with these depths. So this is the cluster that we have, and let's do it from minus 0.5 to 1 and 0 to 1. Okay, so this is the cluster that we have. Okay, so now we want to divide this cluster into 4 rock types. The highest quality rocks, that is the rocks with lowest shale volume and the highest effective porosity, will be called rock type 1. Let's say that this rock type with greater than 20% porosity and less than 10% shale volume will be rock type 1. Rock type 2 similarly will have greater than 15% porosity and less than 20% shale. Rock type 3 will have greater than 10% porosity and less than 30% shale, and rest of the rocks will be classified as rock type 4. So next we can go to the calculator and use multi-line formula. So let us first make the rock types based on effective porosity only. So let's name it rock type and let's save it in the calculated folder. So we will use a if calculator. The logic is if the given condition is true, then it is rock type 1, else if the given condition is true, then it is rock type 2, else if the given condition is true, then it's rock type 3, else it is rock type 4. So we will write if the calculated effective porosity is greater than 20%, then it is rock type 1. Add another line. If this is greater than 0.15, then it is rock type 2. So remember, we are doing it based only on the effective porosity right now, and then I'll show you how to get it more complicated. And then add another line, and I think you can copy and paste this, Control C, Control V. So if the porosity is greater than 10%, then it's rock type 3. Otherwise, it is rock type 4. So this is a logic similar to what you will find in Excel sheet. So let us choose the correct options here. So we want to use all of those lines. So correct. And these equations are continue of this equation. So we will choose continue. And then if you want the output from those equations, so we will just put output in the first line. So that takes all the equations into account. We do not have any units because these are rock types 1, 2, 3, 4. Then check these two. Okay. And let's see. So let's run it. So it should make something in the calculated folder. So let's check. So we have to correct this. I think there is a comma needed here. And then run all. Okay, so now it runs. Okay, so make sure the commas and the brackets are there in correct numbers. So now it should create okay. So I think we need to choose this again. Run all. So now it has created the rock type here. We should delete because it created in the default folder. Delete. Yes. Okay. So now we have the rock type here. So we should just check if it was created or not. So right click. So see, the rock types have been created. We just click here. Then we can see rock types between 1, 2, 3 and 4, numbers between 1, 2, 3 and 4 there. Okay, so we are good here. So you can save this. We can name it like a rock type. Multi-line formula. Okay. Next, we can do, now we can include, remember we said that we will base it on porosity and shell volume. So this was the simplest case with just the porosity. Now let's see how to incorporate the shell volume. So because there are two conditions now, we have to add an and then put the second condition here, which is what? Which is our VSH mix should be smaller than 0.1. Okay. So just put it there. So we just cut paste it. Okay. So what we can do is this should be smaller than 0.1. Okay, now let's see. If we can do this. And let's change these numbers. 0.2 and 0.3. Okay. So make sure that all the brackets and everything are correct, otherwise it will give you an error. And let's name it rock type new, because we already have rock type from the previous calculation. And let's run off. Again we have some problem. Okay. Let's grab the ands here. Let's see if it runs. Okay, now it ran. So we have rock type new here, and again rock types were created. So we are good with this formula. Now let's open our cross plot and open the edit format, and let's add a z-axis here. Let's add the rock type new. So let's use that on the z-axis, and since there are 4 rock types, we can use 4 colors. And we will not, we will just keep the depths as they are, and then apply. See, now our rocks have been divided into 4 rock types, and this is the one with the highest porosity and least amount of shell, and this is the one with the lowest porosity and highest amount of shell, effective porosity I mean. And Let's make a second z-axis and see what happens. Let's color it by gamma ray. Okay. So see, the color did not change, but there are they tried to color the gamma ray they tried to discriminate the gamma ray using these letters A, B, C, D, E, F until J, and you can see that those points have been turned into letters, but it doesn't help that much. Okay, you can make, instead of 10 you can make 4. So I don't think it helps that much, so we can just keep it without any second discriminator, second z-axis. Okay, so keep it like that. Now let's color it only by, so remember this, okay, this plot. Now color it only by the porosity cutoff that we used, using only rock type, and apply. See, now it changed somewhat. Now it's only based on porosity. So you have colors here which was earlier green, now it's pink, and now these were also green before, now they are in different colors because it's only the porosity cutoff that we are using. If you want, you can save this cross plot file, save the format as, let's say, VSH mix PHI cross plot. Okay, save, yes. Okay, so that you can access it later. Now we can close the cross plot. Now we can display our rock types in the log panel. So we can first save it. I think we can save it again in the rock type formula. Yes. Okay. So let's display our log panel. And drag the rock type based on only porosity, and then also drag the rock type based on both porosity and V-shell. So you'll see some differences between the two because different conditions were imposed on the rock types, right? So however, if you just look at them like this, then it's not very easy to visualize them. So we can put some colors and make them more appealing for visualization purpose. So let's put some colors. So let's choose the shading type as variable, and then we define it. Shading should be controlled by rock type new. And there are 4 rock types, so value will go from 1 to 4. Okay. So, and we are using this spectrum. Okay. So the fixed value will go from 0 to rock type new. Okay, let's apply it, see what happens. See, now there are colors there. Okay. Now let's Even this one doesn't look good, so let's put some numbers. Let's put it from 0 to 1. See, when I put it from 0 to 1, now there are uniform colors capturing all the spaces. Okay. Okay. So what do we observe here? See, if you look at, let me try it here. See these blue colors, or let me. So we have these good sands. See, they are shown in red. You see these good sands with low water saturation. They are shown in red. Okay. But and then the others are shown in blue. Well, look at this. Even above this area, we see the red color. We should not see that, right? Because these are the rocks that we do not want. These are the non-reservoir rocks. Still, they are colored in red. So we need to change this color scale. Okay. So let's change the color scale a little bit. And so see why this is happening is that because the end, both extremes are red. You see here and here both are red. So that's why you are getting this type of red, like both rock type 1 and 4 are getting red colors. So let's change it to like a 200. So 200 would be somewhere there, okay? Because this is 256, so 200. Okay, apply. Now see, these rocks are in different color, and these reservoir rocks, like this one is in red, this one is in red, this in red. Okay, so if you want, you can keep that scale, or if you want to try something more, then you can go and use palettes instead of spectrum. So this bars map, let's see what it looks like if we apply that one, apply that palette. So there are many different palettes here, so apply that one. Okay. See, now it's this color, and the good rocks, rock type 1, are all in white. So generally this is not very appealing to put something in white like that, or in like this color doesn't look that good. Okay, so how about we choose another one, like you see it will use a different spectrum of blue for different rock types. So okay, apply. Now you see these are different spectrums of blue. So since all of them are blue, it doesn't look that good, correct? Because it could be confusing sometimes. Light color is the good rock and the dark color is the bad rock. How about we use the brown? Okay. And then okay, apply. See, again the same thing, correct? So a white color here, and then the bad rocks are in brown, and then everything in between, different shades of blue. Brown. Then we can use another one, like how about this one? You see, this is called contrast palette. Okay, so we have this color, and if you like it, you can keep it. There is no recommendation for anything, but let's try another last one. Like use the blue, green, red, this one. Okay, apply. Okay, now what you see, now you have these colors. I like this one because red is generally seen as a warning sign, and here all the bad rocks here are colored in red, and the gas sands are in blue. Okay, so you may have a different choice. You may say that, okay, because sand is shaded, this gas zone is shaded in red, so I want red. Okay, that's fine, but red can also be shown as a bad rock. Okay, so let's keep this one. And but what I suggest is use a consistent coloring scheme that gives the rocks physical meanings in your mind and helps you remember what the colors mean, so that you can associate rock types with different physical properties. That's what I do. Okay, so close. Now let's do the same coloring scheme for rock type, which was based on just porosity. So we have the rock type chosen, and left and right scales chosen properly. Shading variable, we have defined the shading scheme. Okay, so press OK, and now we have the colors here. Obviously it will not match exactly, but nevertheless it's a good match here. So finally, let's see these rocks on the cross plot, so how they look like. Yeah. So I'll go to the cross plot and load format, and we have this cross plot. Okay. Okay, so let's make some observations. These best rocks with low water saturation, like blue ones. So notice here when I'm moving my scale, the mouse here. Okay, so when I'm moving my mouse on these blue rocks, which are the best rock types, then you can see them on the blue one in the cross plot. And when I move my mouse in these bad rocks in this zone, okay, in the heather and above, then you can see it's moving in the green zone. Okay, and then if I put some color on this one, so let's see. You see where we get the highlights, we get at the edges of those good rocks, we get at the edge of those curves. Okay, so we're just transitioning from the best rock to some good rock here. That's why we get it on the edges, and the best rocks are right in the middle. Okay, the blue ones. Okay, so make sure you make these checks for correctness before you accept this rock typing. Only a small portion, so how would you check that? See, only a small portion of this entire rock is a good rock type 1. So you see it's a very small portion, and we agree with that because most of the log is a like a rock type, like a bad rock. Okay, then so this is the bad rock, which is not a reservoir, and that occupies most of the logs. Okay, and you can think of what happens in the middle. Okay, so this is the least, this is the most, and then it's in the middle. These things are in the middle. So you should make these types of cross checks for correctness, so that any mistakes you made earlier for inputting different values or selecting different properties can be corrected. And obviously these colors that you see here, these colors and these colors will not match exactly unless you have figured out a way to do that. For example, you can play with the number of colors here Like instead of 4 you could use 6, apply, and then this changes the color a little bit. Similarly, you can play with different number of colors here, or try so we can go back to 4 here, or you can try different rock palettes here, like play with the different palettes in order to see if you can somehow get a good match between the, so there are many different palettes. Okay, so you can try different palettes and see you can get a good match between the log panel and the cross plot coloring.